Hello everyone, today is the third class. We will talk about aggregation and granularity. According to the dictionary Webster's, aggregation means a group, body, or mass composed of many distinct parts or individuals. If we talk about data aggregation, it means the process of gathering data and presenting it in a summarized format. The data may be gathered from multiple data sources with the intent of combining these data sources into a summary for data analysis. According to Tableau glossary, aggregation is a result of mathematical operation applied to a measure. Let's take a look at the videos.
Welcome to this video on aggregation, granularity, and ratio calculations. You can download the exercise workbook to follow along in your own copy of Tableau. Calculating rates or ratios is a common need in Tableau. However, if we were to create these calculated fields without understanding what Tableau is doing to compute our answer, it can be very easy to get this wrong. Let's step back and go over a couple crucial concepts: granularity and aggregation. If we plot profit and sales, we only get 1 point. Tableau has aggregated the sum of sales and sum of profit and plotted that. If we want more marks in our view, we need to change the granularity, or the extent to which the view is broken down. Increasing granularity is done by adding dimensions to the view. Putting segment onto color breaks that single point into 3, a point for sum of sales by sum of profit for each segment. If we add market to size, we now have 15 marks, and there's now a point per segment for each market. Changing market to another shelf, such as shape, hasn't changed the granularity of the view. We still have 15 marks. And those 15 marks are still the sums of profit and sales for that combination of dimensions. Here, this mark is the sum of sales and sum of profit for the corporate segment for the USCA. The value of profit and sales is the aggregation that depends on the breakdown, or granularity, of the view. The detail shelf is a way of impacting the granularity of the view without encoding a field by color or size or shape. Let's see what it looks like if we put customer ID onto detail. We don't have a shape or color per customer, but our view now shows marks aggregated to the granularity of each specific combination of segment, market, and customer ID. Okay, so why do we care about all that when we're just trying to make a profit ratio? The key point for calculations is that the way Tableau calculates depends on the aggregation of the data. Therefore, it depends on the granularity of the view. Here, Tableau has summed the profits and sales for all orders in each category and presents a value for each. If we drill down to subcategory, we see the summed profits and sales per subcategory. If we expand out to row ID, we see individual records. Keeping that in mind, let's look at how to calculate a profit ratio. Here we have two calculated fields: profit divided by sales and sum of profit divided by sum of sales. In each case, the formula is simply what appears in the name. When we're at the record level, they give the same answer. However, when we roll back and look at our subcategory level, it starts looking really weird. Suddenly our ratios don't match, and the profit sales one here in red has huge numbers. What's happening here? When Tableau aggregates the profit divided by sales calculation to the granularity of the bar chart, it's summing the ratios themselves. A profit ratio has been calculated for each record, and those ratios have been summed. This is very different from what we want to do. By contrast, the second calculation, sum of profit divided by sum of sales, sums the profits and sales at the granularity of the view, and then takes the ratio of those two numbers. If we roll back further to category, the green ratio is still correct. By putting the aggregation into the calculation itself, we let Tableau know when to compute the ratio regardless of the granularity of the view. In summary, sum of profit divided by sum of sales sums the profits and sales to whatever the granularity of the view is, then computes the ratio at that aggregation. Profit divided by sales computes the profit ratio at the lowest level of granularity, then sums the ratios to the requested aggregation of the view. That's a quick lesson on aggregation, granularity, and ratio calculations. I hope this helps explain some of why Tableau behaves the way it does. We invite you to continue with the free training videos to learn more about using Tableau.
So coming back to aggregation, normally aggregation would be done on measure. We remember that we have two types of data. Like one is the dimension, which is sort of like the column header or the attribute names. And then the other one is the measures, which are the values that would change. Aggregation can be done on dimension as well, but the application is very limited. The aggregation on dimension would usually be just counting. That's the limitation. We can do only counting on the dimension. Predefined aggregations in Tableau include summation and average. Dimensions can be converted to measures by aggregating them as a count. By default, or usually, Tableau would aggregate measures as a summation when you place them on a shelf. So aggregation refers to how data are combined. Examples of aggregation is taking the average of all the temperature readings around Seattle on a given day. By default, measures in Tableau are always aggregated. The default aggregation in Tableau is sum. And then we can change the aggregation to other things such as average, median, count, distinct, minimum, and etc. So when I say that by default, Tableau will do aggregation, that is, if we drag some measure onto the column or row, you would notice that it will appear as a sum. Like by default, it would usually appear as a sum. Next, we will be working with um, the data. Go to Google Classroom and download the file NCHS life expectancy at birth or race. And let me just try to show it. In here, the data would look like this. It will have the year and the sex, whether the data is like just for female or both sexes or male. And then it has the life expectancy and adjusted death rate, age adjusted death rate. Okay. So let's go and open Tableau and connect to the data, life expectancy data. So I go to my application, open up Tableau. And then go to Microsoft Excel and go to the directory that you saved the data. Is life expectancy NCHS. And so this would be the data. It would look like this. Since there's only one sheet in this Excel workbook, then it would just load automatically this one sheet into the data pane. So you don't need to drag and drop. So this would be the year, the sex, life expectancy, and age adjusted death rate. So next we will just let's see what is meant by default. That in Tableau default would be the aggregated value. So just go to drag life expectancy onto the rows. Go to sheet 1, life expectancy. I'll just drag it to the row. And then here, see, it just appears as a sum right away. And since like we have only the row value, then it's like aggregated. If we want to make it like disaggregated, then we granulate it or like drill down. So by drill down is to give it another dimension such as the column in order to like break it down into the different coordinates. So now if we want to plot the value of life expectancy by year, then we want to drill down to the year detail, then place year, drag the year to columns. Then it will show the graph. Let me just try this measure. So we have year that's discrete and continuous. Let me try what it looks like for discrete. So if we do discrete, it would just be like a column, like a bar chart. And then if we do continuous, then it would be a line chart. Let's see what else can we do. We can do, I don't think this makes sense for the dimension, which is year is like a dimension. Let's just play it around. Median, it doesn't mean anything. Median year, it just takes like the middle of the year, the median of our year data. Let's just not do it. Count. It would just count how many years we have. Count distinct also. Would just not repeat like the same data. And let's just put it back to dimension because our data, the year is actually the dimension. This is granulated into the years. That means like it's drilled down or granulated, meaning that the level of detail is more now according to the year. And so if we want to separate it even more, let's say you want to see the differences between different sexes, then we drag sex to color. Then it shows different lines. So male would be red, both sexes is blue, and then female is yellow. Let's see if we can sort of change the color. I'll do like we double click on here, and then let's do blue for male because it makes more sense. And then female would be red or pink. And then both sexes just do yellow or orange. So we can also change the color. So this is drilling down or like getting into more details. Now let's see next. If we want to create like a table, let's make another sheet. So this one is life, just name it some life expectancy by year. Let me create a copy, duplicate. This one, the first one is life sum life expectancy. And then this one we're going to do by year, and sex. Okay. Now next, we want a table. Drag life expectancy into the row. I'll just create a new sheet. Drag life expectancy into the row. And we want to show like, now we want to make sure like we understand the level of granularity. So we drag this into the row and then we choose table from show me. Show me is here. And table. And then we drag the year to column, which it looks weird. So let's see, what if I do discrete? Now it looks better. Because like if it's continuous, it's gonna be like overlapping on each other. So if we do the table, we have to choose year as discrete. But if we are doing line graph, then the year has to be continuous. Now we want to see the difference. Now we don't have anything in the rows yet. Like because we just drag life expectancy into the row, which what it did is it did the aggregation. So it just did the aggregation overall the sexes. Now we want to separate it to different sexes, and it could be in the row, the table in the form that would have like the breakdown into the sex. So let's just drag sex into the row. Then we get this. And let's look at, say we want to be able to understand the way that they do aggregation in here, in Tableau. So let's see, focusing on the year 1918. Year 1918, you can kind of like scroll down like here. And then if you sum all of these, just try with the calculator. If you sum all of these, 39, 42, and 36.6, just do here, 19, 18, 39.10 plus 42.2 plus 36.6. And we get the sum is 117.9. And we want to see if this is true. So let's just go back to the graph. This one, the sum life expectancy by year, that's not separated by sex. This is by sex also. So I'll just add by sex. Oh, come on. Somehow I just did by year and sex. So this one is by year only. So I'll remove the sex. So just do this, remove. Then it's just back to, it should be back. Yeah, then it's back to this. So let's just look for 1918. This is 1917. This is 1918. And see over here, life expectancy is 117.9, which is the same as what we have summed over here for 1918. So this shows that Tableau by default is doing the aggregation or the sum. By summing, it's summing over all the entries that appear in the data section. So if we don't separate by the sex, it would just sum all the data that is in year 1918. If we look at here, like it would just add all the data for 1918, 39, and then when we come down, 1918, this, then it would add 42.2, and so on. It just take like sum over all the entries that has 1918 as the year. So that is how it's aggregated. Now next, so just go along and do as I say, then just create the worksheet that looks the same. And next is we will look at the average aggregation. Now average. Well, I want you to go ahead and copy this, the sum life expectancy, duplicate the worksheet, then rename it average life expectancy by year. And you know what we could do, right? So instead of the sum, we would just click here, change it to average. So go to measure and then choose average. It will be the average. And then we want to check if the number is correct and how it does the average. So the average of both sexes, actually 3 sexes, like the both sexes is just like the data that's recorded that they didn't really get the chance to separate what sex it is. So they just put it in this like category, you know, to be both sexes. Or they mix the data all together. So it becomes like another category for the sex. Now, if we average these values, it would be this number. By the way, over here is probably, if we do average, it's going to be average within both sexes and 1918. And then average within female of 1918. and an average within the male of 1918. So let's go to this on the table. Just name this table. This is still life expectancy, which is sum. Let's see, what if I change it to average? Does the number change? Doesn't change. Well, somehow it doesn't change. Does it change? It doesn't. Why does it not change? So this is the sum. And it shows average here. Or maybe because there's only one data. Yeah, I think there's only one data for each. So in this case, average and sum is going to be the same. Just double check, go back to look at the data source. It looks like there's only one entry for each, like the both sets, there's only one entry for each year. So in this case, the sum and the average is gonna be the same. Okay, so now, yeah, it doesn't matter if here is sum or average. Just change it back. So let's go to look at 1918 again. And the data is just the same, right? And then when we do average, it's 39.3. And just go to the graph here. Can I? If I change to average. Now we have 3 data entries, which is like it belongs to different sexes. So 1918, the average is 39.3, which is correct. It's just averaging the 3 entries with the 1918 as the number, as the year. Okay, so yeah, this explains how Tableau does aggregation. Now what's next? Median. So this one is average. I'll just duplicate again and do median, life expectancy. So median is like the middle value. So I'll go ahead here and then change the measure to median. And then let's see, 1918, the median is 39.1, which is correct because if we rank these numbers, this would be the minimum and then the middle and then the max. So this is the median. Okay. Now count aggregation. Count aggregation, basically it just counts the number of entries. So it can be do by count, C and T. Just change this. This one you don't need to do it in the, don't need to do it in data, or just do it. Okay, I'll just duplicate and do count, life expectancy. Let's see what happens. My hypothesis is going to be 3 for all because this one we have 3 entries for all the years. So measure, just do count. So it's 3. And let's try count distinct. It's also 3 because like the entries are distinct, like it doesn't repeat. Okay. Next is min aggregation. So the min within like 1918 is 36.6, right? So I'll just go ahead, duplicate again, and I'll name this min. And then I'll go here, and I'll change the measure to min, minimum. Okay, and then let's look at 1918. The life expectancy here is, the minimum is 36.6, which is correct. Now next, max aggregation. Let's go ahead and duplicate this. Max. You know the drill. So we just change this to max. Max. Maximum. And again, we check like 1918 is 42.2, which is correct. So this, we already did this. We separated into the colors according to the sex. We did this. We did the table. Yeah, so we covered the aggregation. So now I want you to create this worksheet for the part of granularity and then save it as a TWBX. Save it like with the file name granularity. Not granularity. Aggregation.twbx. To use this number, so like for Gavali or this ID, your number would be 1. That means that the year that you will be working on is 1901. And then Tandanai, you're going to be working with 1902. And Pumpat is 1903, and so on. Like Patan would be working with 1910, and then Nirasha would be 1912, Liulom would be 1913, and so on. Just follow this number for the year that you will be doing the next part, which is quite easy. It's straightforward. I'll put this on the slide later. So this one, part 3. Let's just go back and mimic this. Like put the for your year. This is just so easy. I'm sorry. The assignment. And you would want to like show this, okay? Like show the table also, like screenshot of, just follow this like this, but for you would do your year only. So make it into a report. Screen cap the data of your assigned year. Follow the order in the roster sheet. For example, student number 1 will be assigned year 1901. Okay. Student number 21 is 1921. And then for each year, you would want to screen cap and tell like the name, both the screen cap, both the graph that shows the number that you take from the graph, the relevant graph of the aggregated value of your year, and the table value, just like that, okay? Show the table on the left, and then the screenshot of the graph, like with the point, when I click on the graph and then it shows highlight like this. Screen cap it, put it on the right, and do this for all, like the sum. Let's see, just go back to here. We want the sum aggregation, average aggregation, median, count. Oh, count, don't need to do count because it's always 3. Sum, average, min, max, median. Sum, average, max, min, median. Sum, average, max, min, median. Okay, for each, screen cap the table and show calculation of the correct value, and then screen cap highlighted information from the relevant graph. Okay, so yeah, you will have 3 assignments for this part. The first one is you would have to answer these questions. What does data aggregation mean? And by default, the measures in Tableau are aggregated. What does this mean? Explain. So that's the 4.3-1. I will create like a different assignment for each of these. When like for this one, you would type in your answer in a Google Doc. I will create the assignment. And then 4.3-2, you would submit the workbook. That's twb.twbx, named as aggregation. And your workbook would just look like this one of mine here. It would have to have all the sheets, okay? And next is this part that you will submit is going to be a doc, like a document. It could be Word, PDF, or let's just, maybe try to go with PDF. You will be assigned like the name according to your name, and do the screen cap of this. Just follow this instruction. Okay, I will put this in Google Classroom with the instruction. So for for aggregation, you will have 3 assignments. So when it's time, this post will be released at around 4 to 4:30 p.m. on Wednesday. So go to the post for 4.3 And you will see that that's the data file NCHS life expectancy to be downloaded, and then the slide. And in here, the last 3 pages would be the assignments, which I would want you to post the assignment on each of the assignment that will be posted. So you will have 4.3-1 for the assignment, and then 4.3-2 for assignment number 2. And that would be instruction here as well. Instruction here, and then 4.3-3, which that will be instruction over here. So that's the work that you have for this part. That is 4.3. Next part, we will talk about granularity. So before it was aggregation, we know that by default, Tableau will do aggregation. And granularity is the opposite of aggregation. It refers to how detailed the data is. Example is what does a row or the record in the dataset represent? Consider a record of 2 different tables. Say one is a person with malaria, and 2 is a province's total cases of malaria for the month. So what do you think these 2, like which one has a more detailed level of data? Let's think for a bit. So a person with malaria is just like, it has the detail as to the level of a person. But then the province's total cases is like the total, right? It's the sum. So which one is actually granularity and which one is the aggregation? Number 1 is actually granularity, or like the detail as possible, that is to the level of a person. But then number 2 is the case when the data is aggregated into the total number of cases in the province and in the month. So if we talk about the level of detail that is available, actually is number 1. That is the most detailed because it's like drilled down, granulated to the lowest level of data. It's not sum, it's not aggregated. So this is what we call by level of detail expressions. So knowing the granularity of the data is crucial to working with the level of detail expressions. If we go back to look at the data, let's say that the life expectancy worksheet, if we have the scatter plot, let's just pull out the worksheet here. So I'll go and do another sheet. You can add this to your worksheet as well. This one would be scattered plot. And then if we drag adjusted death rate to the columns, it would appear to be the sum, right? This is the sum. It's not yet a scattered plot because there's only one dimension. Now drag life expectancy to rows. Now we have the dot, which the y-axis is just the sum of adjusted rate, death rate. I mean, um, the row is the y column, is the row is the y, which is the sum of life expectancy, and the column is this x, which is sum of age adjusted death rate. Again, it's a sum which is aggregated. Now we want to granulate it. So we drag. This is just similar to previous case, but in the previous case, we drill it down by the year, right? But this one, we will just do the sex. So we drag the sex to color. It will separate into 3 dots of the scatter plot according to the sex. And it's still aggregated within each. It's aggregated over the years for each sex. So we have disaggregated or granulated into the sex. Now, what if we want it more detailed into like the scattered plot according to the year? Then we drag the year into, we cannot make color anymore, so just make it detail. So then it would break up to different circles, like different data points according to the year. And you could probably adjust the size here to make the size smaller or bigger. Now let's undo. Go back. Just go back to the first step, right? And then click Analysis menu and check Aggregate. Uncheck Aggregate. Let's see. Click Analysis or Analytics. Analysis. Here, analysis is up there. And then that's aggregate, right? It's checked. Let's see if we check disaggregate. Then it will show all the points. So this will be all the data points in the data sheet or data source. So that is the scattered plot example of scattered plot of the granularity. Like to make it show all the data, we would go to analysis and then uncheck the aggregate measure. If we want it to be aggregate back, then let's just click aggregate. Then it will go back to the default, which is aggregate. So now I just want you to think of this question. Which level of detail of data is most desirable to have for the analysis and why? Explain clearly with justification at least one paragraph. You may give example. So this one would be assignment 4.3-4, which I would like you to just post it as like the answer to the question in Google Classroom. Okay, you can make it like a doc, or if you can type in just the answer, then just type it in. Okay, I'll go ahead and create this in Google Classroom as well. So let's see, assignment, classwork, create assignment. I'll just do question type, create question. Then you can type in like your answer, I think. Let's try this out. Assignment 4.3-4. Answer this question at least one paragraph. So I'll say ask, and then I'll schedule it. For the 30th, just a Wednesday, and then do 4:45. So this one you could kind of like answer in here, and then I can do the grading. And then let's do due date. I'm sorry, I need to set the due date. So edit, due. I would like this to be due. I really want it to be due before. Well, anyway. So, what time should it be? July 3. Yeah, fine. I'll adjust the points later, so don't like pay attention to the points. So we have in total 4 assignments for this Wednesday class. Like it's more like 4 questions, okay? 4 subtasks. So make sure you submit all the work. Next, we will talk about aggregation and hierarchy. Hierarchy is like a structure that shows how data or objects are ranked and ordered together in an organization or system. So normally hierarchy would mean that you have a set of data with different parameters that are related to each other in a hierarchy level. Like that's the one with the more detailed up to the more aggregated and then higher. For example, is the date dimension, which the highest level of hierarchy is the year, because year is composed of many months. Then like drill down will be month, and then drill down even more will be date. So this is like an example of a hierarchy. Then another example would be the time, starts with the hour, and then minute, and then second. So hierarchy allows analysis in different granularity. You can drill down, meaning work down the level of detail to be more detailed. That is visualizing the data from year down to month. That is drilling down to a single record. Single record would be the date. And then drill up is visualizing data in a more aggregated way. So that is working down, working up from the date to month, and then month to year. So let's take a look at the video from Tableau.
Welcome to this video on drilling down and hierarchies. You can download the exercise workbook to follow along in your own copy of Tableau. Drilling down can mean a couple things in Tableau. Usually, it means expanding out a hierarchy, thereby drilling down to the next level of detail. We'll address hierarchy drill down for the majority of this video. Alternatively, sometimes drill down can mean going all the way down and looking at the raw data. This is very easy in Tableau. Either click this icon here in the data pane to see the underlying source data, or for a specific mark in the view, click to bring up the tooltip's command buttons, click the same icon, and go to the Full Data tab. The command buttons can be turned off in the tooltip to prevent access to this feature in published workbooks if desired. But let's assume we want to easily expand out a series of dimensions to drill down, such as category to subcategory to product name, or country to state to city. Multi-dimensional data sources are limited to their pre-built hierarchies, but if the data source allows it, it's easy to build a hierarchy right in the data pane. Here we see there's already a clear relationship between category and subcategory. In the data pane, to build a hierarchy, all we have to do is select whatever field we want is the next level down, subcategory, and drag it on top of the first level field, category. We'll name this products, and it's that easy. The first thing to note is that here in the pill in the view, there's now a minus sign. Clicking that will roll up our hierarchy, and now it's a plus to indicate there are more levels. Clicking on the plus expands it out. What if we want to make this go further? We can add product name to the hierarchy simply by dragging the field in the data pane underneath subcategory. Note the line showing where it will go. We can also rearrange the order simply by dragging the fields around in the hierarchy. Even though the hierarchy has multiple levels, we can still manipulate each level independently. We can remove subcategory from the view so that it just has category and product name. Note though, if we roll back up and drill down again, the view will redefault to whatever the hierarchy is in the data pane. What if we realize we don't want the drill down functionality anymore? We can either remove a field from the hierarchy simply by clicking and dragging it out, or we can right-click and remove the hierarchy altogether. Let's undo that though. There may be instances when it's useful to have a field in a hierarchy, but also be able to use it on its own. For example, perhaps we want to create a high-level view, where drilling down to the lowest level of granularity could negatively impact performance without adding to the analysis. We want to be able to use a specific field without the drill down option. Simply right-click on the field, select Duplicate, and then use that field in the view. Now it has no drill down capabilities. Date fields, depending on their level of granularity, are automatically brought into the view as hierarchies. Here, when we bring out order date, it already has a plus sign, indicating that we can drill down. If the dates in the data are in a standard format, including year, month, and day, Tableau will recognize automatically the additional layer of quarters and build that out. As always, we can remove an individual pill that we don't want in the view. The default pill type for a date field is discrete, and a discrete date hierarchy will have a different pill for each date part. However, if we right-click and drag out the date, or change the pill type from the drop-down menu, we can select a continuous date instead. Continuous dates still have the same drill-down functionality, but each drill-down updates the pill to the next level down instead of creating a new pill. because continuous dates by definition cannot be considered as separate date parts. To drill back up, open the drop-down menu by clicking on the caret in the pill and selecting the desired level. Thank you for watching this video on hierarchies and drilling down. We invite you to continue with the free training videos to learn more about using Tableau.
So that was the drill down. So let's take a look at the file tiny datasets. Just download it. Download the tiny datasets.xls, and there is only one worksheet, so we don't need to drag the worksheet to the data pane. It would just be up there. And then we want to try to create hierarchy. So select the lower hierarchy dimension, which is school, and drag school on top of state dimension. Specify the name of hierarchy as area. And then we want to use this hierarchy and drag and drop the area. To drill down, we can click the plus, and then to drill up, click the minus. We can also duplicate the dimension, click on state under area and click drop down and select duplicate. And then drag area to row, click plus to drill down, click minus to drill up, drag score to column. So let's just try that. So let me open up Tableau. And then download or unload the tiny dataset data. And so notice that there's only one sheet, so the sheet would be here already, the data. And then I click on this one, and we want to create like a area hierarchy in which the school is the lowest level of hierarchy. And then state is the higher. So school and state. So what I'll do, I will just drag school to the state. And then name this area hierarchy. And then it will appear here, area and state and school. And if you want to duplicate this, just duplicate. And then it will show this like as a no hierarchy, school, and state, which appears to be the copy. So let's just try to drag area to the column or whatever here. So first it will show the level, like the bigger level, which is the state. And then I click plus, it will drill down to school, So it will have state and school. And then if I click minus, it would just bring it back to the higher level, which is state. Let's see this one. Because we didn't drag any measure, let's just pull this to here, row. And then drag score to be the detail or text, because you want it to here. So text. Then school will appear up here. Let me try, what if we make it detailed? It doesn't work. Next is about problems with aggregation. There are some things that we have to be careful with when we do aggregation. So there are things to be careful with aggregation because it can create problem. Notice that normally Tableau will do aggregation as the default. And then the way that it does aggregation is it would just sum of all the entries. So for example, if we create like a calculated field that is named ratio, and then we use drag it to the data pane or to the column or row, it would just show aggregated ratio, which would be the sum of our ratio. And just a revision that we can calculate like the calculated field by clicking any column and then right click and select create calculated field. Then name the field shipping cost to sales ratio. Or we can just create calculated field on the worksheet. Then if we drag shipping cost to sales ratio to the row, it would just be aggregated of all the sales ratio. Let's just take a look at the Excel file. If you open up the aggregate function .xls, then you will see that there are two ways. What is happening? If we calculate the shipping cost to sales ratio, like do the shipping cost divide by sales, we get this value. And then if we add all of the ratios together, the value would be greater than 1, which is not true. If we want aggregated ratio, meaning like the sum of our shipping cost here over the sum of our sales here, which is like sigma shipping cost over sigma sales, then this is totally wrong. What do we have to do? It has to be the sum of the shipping cost of what we are considering divided by sum of the sales of, like, let's say the first 4 rows. So it has to be this formula here. That is, so if we want like the total ratio of the all overall shipping cost over the overall sales, we have to divide E10 divide D10. This is like the formula in Excel. So let's just go back to look at Tableau. What is happening? So let's say we open up Tableau. the file, which is Global Superstore. And open. Something is just wrong. Okay. Why doesn't it show any data? It's loading. It's very slow. Okay. And then let's see. In data sheet, we don't want returns. We want, let me just remove this. See orders. Shipping cost and the sales. And let's say we want to create like shipping cost to sales ratio. We click on any cells. It could be any cells at all. Create calculated field, and then ratio, shipping cost. We name it shipping cost to sales ratio, and then this would be equal to the formula, which would be shipping cost here, shipping cost. So we type ship, and then we just choose this one, divide by sales. Okay. Then this is shipping cost to sales ratio, which I can't really see it, so I'm just gonna rename it ratio, shipping cost to sales ratio, okay? And so this would just, if we sum all of this, let's just see what happens. I'll go to here, sheet. And then I'm just gonna drag shipping cost to sales ratio to row. Shipping cost to sales, which I named it ratio. Here, ratio, drag to row. Let's see what's happening. It's very big. It's like 5,500. So what happened is it was summing like all of the ratio, which is less than 1, but then when you sum them all up, it becomes really large. It's the same as what's happening here. So what do we need to do? If we want it to be the ratio of total sales, total shipping cost over total sales, then we have to change this. Just go to here in the calculated area here. I'm just double click here, edit to edit formula, and then I'll type in sum, and then sum of this over sum of sales. Let's see, and then okay. The values here don't change, but what will happen is once we go to aggregate, it should change. Let us see this. What's happening? I'll remove it, and then do sales ratio. Now the value is less than 1, which is correct, right? This is aggregated. And let's just see, what is it? 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 some by any chance? I think so, yeah. So that's what we have to do. We have to put some in there so that when it does aggregation, it will first sum the shipping cost of all the entries up to like in the aggregated, and then it will sum separately the sales before it does the ratio. So that's how we correct this. Okay, so this is just like the problems of like the questions that you should be able to answer. What is the problem discussed? Like what was happening with the global superstore case? What caused it? And how did we solve it or how to solve it? So this would be another assignment. 4.3-5. Okay. So make sure you finish all 5 assignments before the end of Saturday. I'll see you on Sunday.